As we can see in previous model, it is more natural to include more than one predictor in regression models. The growth of response is determined by multi-factors. In this video, we will apply multiple linear regression model to generate a signal for the growth of SPY, the exchange-traded fund which tracks S&P 500. We finally come to the most interesting part of this course. We will build a model using multiple indices from the global markets and predict the price change of SPY. The reason to choose SPY as a target to build a regression model is because it is very suitable for trading frequently. It is cheap. Each unit of SPY is worth approximately 1/10 of S&P 500 index level. To earn a SPY, it requires very low fee ratios. Volatility of SPY is very high. 2 digits loss and gains rates appear often. We will predict daily price change of SPY when US market opens in the morning. We know that different indices in different markets are highly correlated. Using indices from other markets is good for prediction model of SPY. Secondly, different markets are in different time zones. For example, US market opens at 9 a.m. and closes at 4 p.m. Eastern Time today. Europe markets open at 3 a.m. and close at 11:30 a.m. Eastern Time on the same day. That is, when US market opens, half-day data of Europe market is available. Asian markets, including Australia, opened at around 8 p.m. Eastern Time yesterday and closed at 3 a.m. Eastern Time today. That means the Asian market information is available for US market at its opening. In this video, we will use all ordinaries from Australia, Nikkei from Japan, Hang Seng from HK, DX from Germany, CAC 40 from France, S&P 500, DJI, and NASDAQ from US market to predict the daily price change of SPY. In the next video, we will demonstrate how to use prediction model in paper trading, that is, to trade using historical data. This data can be downloaded from Yahoo Finance easily. We did not use FTSE 100 from UK, which definitely is an important index, because it is now not available for downloading from Yahoo Finance. You use a data frame from CSV to read the CSV files of all indices and SPY. All datasets have 6 columns. Open is the price at the beginning. High, low are the highest and lowest prices on that day. Close is the price at the closure. Adjusted close price is the adjusted closing price that has been amended to include any distributions and the corporate actions that occurred at any time before the next day's open. Volume is the number of shares traded on that day. In our demonstration, we will only use open price to simplify our discussion. Different from simple linear regression, multiple linear regression will have multiple predictors. Our response variable is open price of SPY tomorrow minus today's open. With this response, we expect to make a prediction in the morning in US market. Based on predict price change, we decide whether to long or short. Here, totally we have 8 predictors. Just a reminder, we cannot use any information available after the opening of US market on current day to calculate predict values. In other words, these variables cannot be predictors. We will have 3 groups of predictors. The first group is 1-day lagged variables from US market. Open minus open price of last day for SPY, SP 500, NASDAQ, and DJI. The second group is 1-day lagged variables from Europe markets. Open minus open price of last day for CAC 40 and DAXI. Ideally, for European markets, we want to use price at noon minus open price. If you have intraday data, you can improve this model. However, Yahoo Finance does not provide intraday data. Last group, close price minus open price of AOD, HSI, and the Nikkei in Asia and Australia markets. Next, we will monitor the data to get all these predictors and the response. First, we generate an empty data frame and let the index to be the same as the index of SPY. Then we add columns of response and predictors we defined in last slide. Notice, in the last row of codes, we keep a record of open price of SPY, which will be used in the next video. If we print the head of this table, we find missing values. This is due to two reasons. When we calculate price change, we may generate NA value in the first row, 1 day lag, and the last row, 1 day in the future. In different markets, they may have different holidays in which the markets are closed. It can be shown by computing numbers of NA values in each column. We find Australia market seems to have more holidays. We need to handle NA values first before we build a model. First, we use feed-forward method to feed the holes of data frame by propagating last valid observation forward to next valid. Second, we drop the first row by using drop NA. We can check if there is any NA remain by computing numbers of NA values. From the printout, it is clear that we fill all holes. Finally, we save our clean data into data file, indice panel.csv, using method toCSV of data frame. We will use this data in next video. We can print the dimension of data. Totally, we have 2,677 days of data, 1 response variable, 9 predictors, and the last column keeps a record of open price of SPY, which will be used in paper trading. To make sure that our model is consistent in feature data, we need to split data into 2 parts. One is for building the model, the other part is for testing the model, to see if the model can still make reasonable prediction in this data set. Stock data is very noisy comparing to other static data like images. We will use an equal size of samples for both train and test. We assign the most recent 1,000 days as the test data and 1,000 days before the test as the training data. Firstly, we use a scatter matrix to get a pairwisely scatter plot. If you check the scatter plots between response SPY with other 9 predictors, you may find that there is no explicit pattern, which is evidence of high noisy properties of stock markets. We need to compute correlation in order to see the association clearly. From the output of correlation, we find that the predictors from Europe and Asian markets do have association with SPY, which have higher impacts than predictors of US markets. We can use OLS method of stats models to build multiple linear regression model. The summary is printed out. There are a couple things we need to pay attention. The first thing is the p-value for F statistics. F test is for overall significance of the multiple linear regression model. If we reject, we accept alternative, and it means that at least one of the predictors is useful. Our model is better fitted than intercept-only model. P-value equal to 0.0106 in our model, which is less than 0.05, and it indicates that our model includes useful predictors. Summary table also lists the p-value for the test of significance of the individual predictors. From last video, we know that p-value of test statistic are used for this test. For our results, we found that most predictors are not significant, except A odd. That means that all other predictors are useless in prediction of SPY. It may be because of multicollinearity. Multicollinearity refers to a situation in which two or more predictors in a multiple regression model are highly linearly related. One predictor can be predicted from the others with a substantial degree of accuracy, and it is typical for our model since all indices of different markets are correlated. Multicollinearity does not reduce predictive power. In this situation, the coefficient estimates of the multiple regression may change erratically in response to small changes of data. Now we can predict daily change of SPY using method predict of our model RM. We predict SPY in both trend and test. We can further draw a scatter plot between real daily change and predict daily change of SPY. It does have positive correlation, although not very strong. Consider it is a daily trend, this result is not very bad. Next, we will evaluate our models by comparing two statistics in trend and test. First statistic is RMSE, which is the square root of sum of squared errors averaged by degrees of freedom, where K is the number of predictors. This statistic is to measure the prediction error. The reason to use the degrees of freedom is that square of RMSE is unbiased estimator of variance of noise. The second is adjusted R-square. In simple linear regression, we use R-square to get a percentage of variation that can be explained by the model. We found that by adding more predictors, the R-square is always increasing, but the accuracy is even worse. To compensate the effects of numbers of predictors, we have adjusted R-square, which measures percentage of variation of response that is explained by the model. We will compute R-square and RMSE in many practice, and we do not want to write similar codes repeatedly. In Python, we can package these codes under a function name so that we use these codes repeatedly just by referring to the function names. The keyword def is a keyword to define function, and return is keyword to output your result from the inside of function. Functions to compute adjust R-squared and RMSE is given, where the parameter model is a model name and model K is the number of predictors. Y name is a column name of a response variable. Then we compute adjust R-squared and RMSE for both trend and test using function adjust metric. We give another function access table to generate an output which compares the R-squared and RMSE between trend and test. We compute RMSE and adjust R-squared in both trend and test in order to check whether they are different dramatically. If so, this is called overfitting. Usually for overfitting model, RMSE and adjust R-squared is much better in trend than in test dataset. Then it implies that we cannot apply this model to real market in the future. From the output of our model, RMSE increases in test, which is a bit worse than that in the trend. Adjust R-squared in test is better. Overall, our model is not overfitted. Our R-squared is only 1.5%, which is quite low, but in stock market, it's not that bad. In next video, we will use predict value of our model as a signal to buy and sell SPY in both trend and test to check whether the signal could generate profit consistently.